So I'm now going to hand it over to our case study presenters for today. So Jim Latta is currently the manager of facilities capital programs for SoCalGas. Mr. Latta joined SoCalGas in 2003 as a project manager. Prior to that, he worked 18 years in the aerospace industry for Hughes Electronics, ultimately as Senior Director of Administration for Pan Am Sat Corp. He graduated from Cal State University, Long Beach with a BS in Business Administration. He's a proud father of 2 adult daughters, and I'm editorializing a bit here, but he seems anxious for a few grandchildren as well, and he's a Long Beach resident. Secondly, we have Mike Boyko. He is the principal and co-founder of Dynamic Water Technologies. Mr. Boyko has been working with water treatment systems and pollution control technologies for industrial manufacturers, power plants, mining operations, and other industrial sector since 1991. He has extensive expertise in electrochemical technologies, chemical scrubbers, thermal oxidizers, dust collectors, bulk material handling, and other technologies. He served on the board of several public companies and regularly consults with the power industry, manufacturing, and mining groups around the world. Along with his co-founder, Dynamic Water Technologies was founded with the idea that through the implementation of better treatment technologies, we can conserve water and reduce chemical additives while still providing savings for the end user over traditional treatment methodologies. Dynamic Water's technologies are time-tested solutions used around the world. So with that, I'm going to hand it over to Jim and Mike.
Yep. Thanks. Appreciate the introduction. This is Mike Boyko. If we can go to the next slide, please. Everybody's pretty familiar with the primary challenges, which is scale, control for cooling towers, corrosion mitigation, and biocontamination control. All these are very costly and potentially dangerous. When scale happens in the, as we mentioned, in the concentration of cycle rate, you have to mitigate that issue because that scale will form on heat exchange surfaces. It acts as a very effective insulator. Same with biofilm, which actually will cause a significant reduction in energy, increase in energy use and decrease in energy efficiency. That's something else that if you keep your scale and biofilm surfaces minimized, you're going to optimize your process. Corrosion, again, is more of a long-term issue. And again, by mitigation of the scale and biocontamination, many times corrosion becomes a problem because of the implementation of certain aggressive chemicals. Next slide, please. Now, traditional chemical water treatment, which is the primary process, you're typically going to be using inhibitors to prevent the scale and corrosion. You're going to be using biocides, and then you're going to be balancing the water using a series of various chemicals. Water service technician is typically going to come, to your facility once or twice a month, depending on the facility. Some of them have it more often if it's a more intense application. Next slide, please. Chemical blending, typically is an effective treatment technology. You do have to be very cautious and careful about how to manage and operate those processes because water is ever changing. The application's demand are ever changing. You're definitely dependent upon the technician's skills, if it's been dosed right, if it's been managed right. And that goes back to one of the references from previous. It's really important to have a good controller managing the water chemistry on your system, as well as dosing of the chemistry into the process. Next slide, please. Our particular technology is using electrochemistry, but basically observing the same type of operational conditions. Basically, we end up generating biocide as well as pulling out certain mineralization using electrochemistry. But essentially, it's the exact same process. It's all a chemical balance, basically about managing the biocontamination, the scale control in the process, and overall optimization of your process water. Next slide, please. We're using a low voltage DC current and basically energizing a titanium anode in the center of the cathode. And what this is doing is generation of chlorine and hypochlorous acid, while we're also allowing any kind of calcium and magnesium to form on the wall of our reactor. So this is essentially doing the exact same thing about pulling unstable mineralization out of the process water and allowing for overall better water management of the system. Next slide, please. As the hard minerals are pulled out of the system, we're able to minimize the actual makeup water that's necessary to go in, so we can increase cycle rates and run at a higher concentration of overall minerals. The actual salts or chlorides in the water are then utilized in our electrolysis process to generate chlorine and hypochlorous acid to act as your active biocide. Next slide, please. So inside the reactor, you can actually see inside the shell here, we're actually forming some of the mineralization inside the tube itself. We use an automated cleaning process to actually wipe those minerals out of the tube on a periodic basis. And again, in the center of the tube, we actually are forming that low pH zone where we have chlorine and hypochlorous acid. The additional advantage we have in that is that in that low pH environment, the chlorine is hyper effective. Next slide, we'll actually turn it over to Jim Latta. Jim?
And thank you, Robbie and Tara. SoCalGas is the largest natural gas supplier in the U.S. We have over 14 million customers. We serve from the Mexican and Arizona border all the way up into central California. And several years ago, our executives challenged the facilities department to really have a dramatic impact on reducing our resource consumption, even natural gas, but especially water and electricity. So any of you, if you have any excess water, please send it to Southern California. We could certainly use it out here. But we partnered with Dynamic Water Technologies a few years ago, first and foremost at our Energy Resource Center. Energy Resource Center is one of the very first LEED certified green buildings, and we're very proud of it. Next slide, please. So it's primarily the Energy Resource Center is a public facility. We do customer service, we do training, we make it available to the public. There is a mezzanine upstairs that does house some personnel. You can see the stats on what our mechanical systems are there, and we finally were able to commission a site about 2.5 years ago with Dynamic Water. Next, please. Like I said, one of the things we really wanted to do was, especially in Southern California, reduce our water consumption. And the ERC and the next facility that we will highlight were our two biggest water consumers. Out of the 7 regional headquarters we have over 200 sites throughout Southern and Central California, but we have 7 regional sites. These were the 2 biggest water consumers, and so these were the first 2 that we targeted. Next, please. So I do have a business degree. I'm not a chemist, but among the other things we were hoping to achieve by partnering with Dynamic Water was the reduction or elimination of the use of chemicals and water treatment. And in addition to that, we also wanted to, and I think Robbie touched on this earlier, we wanted to eliminate the potential exposure to Legionella and other airborne viruses and bacteria.
So I'll actually take over, Jim, on this one.
Yep.
One of the other things that we manage, basically, it's the mitigation of corrosion, because as you're managing biologic control as well as scale formation, some of the traditional methodology using acids or other technologies can actually, like if you use softened water without any kind of inhibitor, or if you were to use an ultra soft water just coming into the process anyway, you could experience excessive corrosion. We introduced what are called corrators to the process monitoring, and through the use of our technology and the increase in concentrated soluble minerals, we're able to manage the corrosion levels in the process water at very low rates. The corrators give us real-time data and instantaneous reading of active corrosion that's ongoing, and we typically keep our systems far below industry standards for corrosion mitigation. Back over to you, Jim.
Upon the implementation and commissioning of the system at the ERC, as we call it, I got to see inside some of the cylinders and actually see how bad the scale was, and this is a great depiction of why we had so many blowdowns. We were using a lot of water, and Mike, I think you can speak to the numbers better than I can.
Yeah, we definitely had some great savings from the process. This particular facility was a 73% reduction in overall water savings for the facility. We were quite excited about the results that we got there. It's pretty typical for us. We typically save between 20 and 70% overall makeup water and reduce our blowdown reductions, usually somewhere in the 50 to 90% range. Next slide, please.
So we saw so much success at the Energy Resource Center in Downey, California, that we moved to the biggest water usage facility we had in our service territory, and it's a multi-purpose campus located in Monterey Park, which is just east of downtown Los Angeles. It's our primary data center. It's where all of our remittance processing, so all of our bills are generated there, and all of our payments are come into that facility. So we use a lot of energy, a lot of resources there. And Mike, I'm going to let you, as we get a little further into the slides, talk to the tremendous savings that we've achieved here at Monterey Park. So next slide, please. So here's the stats. We've got 3 large cooling towers, at least for us, they're large. And we implemented 2 4x4 reactor systems via dynamic water, and that was commissioned a little over a year ago. And we're starting to see great results. Our O&M costs our utility costs are going way down, especially on the water side.
So Jim, do you want me to pick it up on this one?
Please.
Yeah, so on the Monterey Park, it was a great opportunity. It's a heavy use facility, and it was a facility with the water conditions were relatively hard. For California, 850 microsiemens conductivity is quite hard water. Although in Arizona we can get even worse, but for California, it's among some of the hardest water in Southern California. What was great about this is we were able to move from about 1.2 cycles past 4 cycles. In fact, I think we're currently right up around 5 cycles of concentration. This represented about a 78% reduction in overall water savings. We also were able to basically push the upper limits on the mineral concentrations. The nice thing is that the projected savings on the system, both projections as well as the measured values, are looking at over 5 million gallons of annual water savings for this one facility. And again, the same type of thing on the overall water balance. We're seeing very good overall control of the process water. And go to the next slide. The same type of results in the control of biologics. We typically are far below, usually 10 to 100 times lower than industry standards, according to CTI, on the colony forming units per milliliter. So we've consistently performed, and monthly we actually perform dip slides, so we get a biologic count every month. We do this at all of our standard customer inspections, just to make sure that we're maintaining really good control on overall biologics. Next slide, please. Similarly, we incorporated corrosion correlators, which basically give us, again, real-time data on the active corrosion levels. And again, we're maintaining those levels at exceptionally low values. Next slide, please. We've also made some significant improvements in the overall design. On the left, you see is our original 4x4 standard process technology. We now have domesticated all manufacturing, and on the right-hand side, this is our new, what we call our DSR system. In addition to making some general design improvements on flow characteristics, what we've also done, we've incorporated a real-time automated cleaning process. And so this process not only has improved the overall general treatment, but it has decreased the actual service cost. And as a side benefit, it's actually, we've reduced our net equipment cost by domesticating the manufacturing processes and manufacturing this product here. Next slide. What I just described there basically is going through this. We have the auto self-cleaning using linear actuated systems. We did dynamic flow modeling basically to optimize the overall process itself. We do have an automated PLC control system that incorporates directly into the system, and all of the component parts in this process, we manufacture everything in the United States now. And Jim, I'll turn the next one over to you.
Okay, thanks, Mike. So we saw such a significant improvement in our water consumption, as well as electrical. So this year, despite the fact that most of our facilities are minimally occupied, we were able to implement 2 new systems, 2 of the new DSR systems, at 2 of our other regional headquarters. One is in San Dimas, California, which is northeast of downtown LA. It's our primary call center. So typically we would have 400 employees there on a given day. It operates 24/7. Last time I was there, which was about 2 weeks ago, most of the people are working remotely, but it's still staffed. We were able to implement the new DSR system at San Dimas, and that was commissioned about a month and a half ago, so we don't have any empirical data to my knowledge. Is that right, Mike?
That is correct. It's still very early.
Yeah. Next slide, please. Yeah, there's the stats. Mike, I'll let you speak to
the
new DSR.
Yeah, so again, there's several areas in Southern California in particular. The water hardness is quite exceptional. This is another one of them. 1,000 microsiemen incoming water is very typical of what you see in Las Vegas and what we're seeing in some of the inland areas in California. Previous set point of 2,300 is pretty typical from what we see in that area in Southern California, so 2.3 cycles. We've moved that to 5,000 microsiemen set point, so basically going from 2.3 to 5 cycles. A projected savings of 29%, which equates to in excess of 2 million gallons at this particular facility.
And immediately upon finishing the San Dimas installation, we moved to Anaheim, which in Orange County. It's our regional headquarters that serves the Orange County area of our service territory. And we implemented another DSR system there. And next slide, please.
This was quite an interesting one, Jim, because this one had to be a rooftop installation. So we ended up manufacturing a custom mounting skid with our installation process. So our fabricator, Steve Duvall, actually custom designed this system. We used a structural engineering group in partnership with SoCalGas to fabricate this assembly, including the automated skid system, and mount it on the roof of that facility. So it's quite a showcase facility. Looks really sharp. And again, the overall projection is about 23% in the excess of 1.5 million gallons. And we're starting those savings already. So.
Excellent. That's a really great case study. Did you have more to add?
I just want to reach out and Tara and Robbie, thanks for the opportunity to present.
Absolutely.
No problem. We really appreciate it.
Same with us. I was going to say, Tara, what I'd be happy to share with you guys, and I'll send it after the fact, some additional case details and material information if you're interested. We're very big fans of documentation. We worked with the U.S. General Services Administration, with the U.S. Department of Energy on 2 separate studies, with the City of Los Angeles. We're exceptionally happy to be working with SoCalGas. They've been a remarkable business partner for us. And it's really nice to have such proactive partners that took it upon themselves to look for these technologies. And it's really a great thing for companies like us that are striving to develop technology to provide this water savings. And so I really want to thank SoCalGas and all of our industry partners.
Well, and we originally met at Edwards Air Force Base, the NASA facility that you guys installed at. And I would also be remiss if I didn't highlight the amount of training and customer service that after installation that Dynamic Water provides.
Thank you.
That's great. You guys have done an awesome job, and it's really great to see such continued progressive savings over time, and also you beginning to scale that up within other facilities in your area. That's really great to see. I just wanted.
Sorry, Tara. I have 3 more projects on the books for next year.
That's great.
Yeah.
That's fantastic. Those are really great examples, because it looks like before using manual methods to remove that scale especially looked pretty difficult too.
Well, our chemical provider isn't very happy with us, but that's okay. We're saving a lot of money.
Yeah. Well, it's always a balancing act. So it's good to see that you've been able to have such great savings over time, and that you will continue to have great savings as well.